Hello everyone, and welcome to today's webinar, Predictive Analytics with Azure SQL Data Warehouse. I am Megan Souza, Marketing Manager here with Dunn Solutions Group. Before we get started, I would like to go over a few items. This session will be recorded, and we will send out a link to the recording to everyone who registered within 24 to 48 hours after the presentation. We also have recordings of all previous webinars on our website in the event that you missed any in the past at dunnsolutions.com. Also, if you have any questions during today's presentation, we encourage you to submit them and we'll address as many as we have time for at the end of the presentation. If the question is somewhat complex and we need more time to answer, we do promise to follow up with you for those. So let's take a look at today's agenda. I will begin by doing introductions to Dunn Solutions Group. From there, we'll turn it over to today's presenter, Renata Seaman-Junta, Analytics Manager here at Dunn Solutions. And Renata will begin by discussing predictive analytics, customer churn analysis, and product recommendation. She will then turn over the presentation to our demonstrator today, Sunil Parekh, and he will take us through predictive analytics with Microsoft Azure, after which we will take any questions that you have and give you any answers that you need. So let's begin. Dunn Solutions has a long history of delivering innovative business technology solutions to companies. We are headquartered just outside of Chicago and have offices in Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into two practice areas. Our application development solutions feature portals, e-commerce, and content-managed websites, mobile application development, and custom application development. Our analytics solutions feature predictive analytics and BI platforms, as well as data warehouse and data integration. We are authorized SAP and Liferay training providers and offer classroom, virtual, private, and custom options. We believe training is important because once we deliver a solution, we want to make sure that those who need it know how to use it and maintain it. Our clients, some of which are included here, are a combination of Fortune 500, mid-market companies, government agencies, and nonprofits across all verticals. About 80% of our business are commercial clients and 20% are nonprofit and government. We maintain strong partnerships with top technology companies in order to offer our clients the most innovative solutions available today. Our analytics practice helps deliver information to decision makers throughout your organization so that it runs better. We can help with decision making by not only looking into the rearview mirror, but also looking forward into the future by leveraging predictive analytics and data mining techniques. Thank you for allowing me to introduce you to Dunn Solutions. I will now hand over the presentation to Renata. Welcome, Renata.
Thanks, Megan. Hi, everyone. So you can see our screen and you can hear me, right?
Yes.
Okay, thanks, Megan. So this is our third webinar of our Azure Data Warehouse webinar series. And this is about predictive analytics. As you may attend the other two webinars, the first webinar is about migrating the premise data warehouse into a cloud data warehouse using Azure Data Warehouse. And on the second one, we try to combine the big data into the cloud when we try to focus on two things, the unstructured data and the real-time streaming analytics. And then today, we are going to focus on predictive analytics using Microsoft Azure Machine Learning. So we're going to use the data coming from Azure Data Warehouse and build the model using Azure Machine Learning. There are two models here, the customer churn and product recommendation. And then once the model is started running, trained, we send back the result to Azure Data Warehouse and visualize it using Power BI. And for product recommendation, we're going to show it in the web page. So that's basically our agenda for today. So let's start. So as we may know, humans have tendency to use historical data to learn from the past and try to predict the future. Even, for example, I like to watch movie and then try to predict what's going to be the end result of the movie. So for Gartner here, what they say is there are 4 types of analytics. Start from descriptive, diagnostic, predictive, and prescriptive. as the value of the analytics is increased, the level of difficulty of building this analytics is also increased. So today we're gonna focus on predictive analytics, and for this we might need some help. Yeah, usually it is the data scientist, data professional, and software developer who are building the model because they are educated and also they have deep skill in math and science, statistics, and computer science. And predictive analytics is using a lot of these techniques, yeah, like data mining, statistics, modeling, machine learning, artificial intelligence. They try to analyze the current data to predict the future. So we're gonna show during the demo that we can reduce the level of dependency of these expert people, yeah. So now let's see what the data scientists are usually doing. You know, in the architect world, the architect usually build a model to communicate their design. In predictive analytics world, the data scientists build a model to, it's like a statistical model for communicating the future behavior, yeah, so to be able to show you how the model will be able to predict the future. So in this case, they follow some steps. Yeah, it's like in software development, we have software development lifecycle. In here, we have the model development lifecycle. So start with problem formulation, where you specify the objective of the model. So if you're trying to develop a customer churn analysis, for example. And then the next one is data ingestion and evolution. It's about enriching the data. You try to get a complete, clean, and also clearly defined data. That's your objective here, because we know if we enter garbage into our model, we're gonna get garbage out of it. So the third one is about preparation and feature. So in this case, we try to transform the data to make it cleaner. We try to isolate or flag any abnormal data. We try to substitute missing value, categorize continuous value into range, or normalize those continuous value into 0 or 1, so the model can easily predicting the data. So in this case, if we are trying to build the customer churn analysis, we need to enrich the data by the demographic of the customer, and we need like a flag to consider the attributes that require for predicting the customer churning analysis. Yeah, we need the field to store the value 0 or 1, whether the customer gonna be churning or not. The next two, the modeling and model evaluation, they are both iterative and experimental, because the objective here is to build an optimal model. Yeah, this includes model training, where we try to select the machine learning algorithm. We try to define the input-output parameter and try to optimize the algorithm parameter. So there are many algorithms out there. We can classify them as supervised and unsupervised, and there are many ways to choose. Sunil will explain about this later. Yeah. The last one, model deployment. This is when the data scientists deploy the model into web services. So it can be called by any programming language or any devices. There are many business cases that the predictive analysis can help. You know, for example, we have fraud detection, real-time advertising, text-based sentiment analysis, and predict equipment failure. So today we show you two business cases. The first one is the customer churn analysis. This is about when your customer fall in love with your product. The question becomes, will they stay? How to improve the retention strategy? because we know getting a new customer is about 5 to 15 times higher than making them stay. So what we can do over here is we try our model, we try to build a model that can predict potential churn early, and then we respond it quickly, by doing some campaign, automatic campaign to try to revive and renew the loyalty. So really need to identify the sign quickly and understand what they need. The second product recommendation, this is about once the customers stay, our question becomes, will they buy more from us? Will they become our best customer? So how to compete in this e-commerce world when everybody sends email, how to get noticed. So they will open our email and then see the product recommendation. So in this case, what we can do, we can access all the data that we have, our product, customer, and purchasing data, and we try to create a more targeted display product in the email or the website. So we help them to buy more products from us. For those of you who have been attending our webinars, you have been seeing this picture from 3 times at least. This is about transformation from a traditional data warehouse into Microsoft Azure data platform, the modern data warehouse. So I'm not going to go through each layer and each component here. We are going to focus on the predictive analysis and what the Azure can do. Yeah. So for this, for today, predictive analytics is about doing machine learning. The Azure Machine Learning is about doing predictive analytics in the cloud. So it's about enabling professionals to build, deploy, and share their predictive analytics models. So we don't have to be a data scientist to be able to use Azure Machine Learning. But we still need a browser and an internet connection. We don't have to install software or acquire more hardware or additional licenses. We can still connect to the rest of the Azure data platform here, like HD Insight, the Azure SQL data warehouse, in-memory column store, even hubs. And in fact, in this today demo, we're gonna connect Azure Machine Learning to the Azure SQL data warehouse and then display the result in the Power BI and ad hoc web application in a notebook, in this case, but it can be seen on the mobile application like your phone or your tablet. So that's, and don't forget, once your application in the Azure data platform, all the benefit of doing it in the cloud, you still have it. So I think this time for the demo, Sunil.
Hey, thank you, Renata. And welcome everyone for this webinar series. So as you already know that, okay, what is the predictive analysis, how it is important, and also we have seen 2 cases, use cases for predictive analysis. One is about customer churn analysis, and another is product recommendation. So I'm going to demonstrate of two of these 2 use cases, and I will show you, okay, how it will look into Power BI, or how we can integrate predictive analytics into our application. So before that, let's move first to understand what is Azure Machine Learning. So Azure Machine Learning is a fully managed and scalable cloud service. You can also call it as a software as a service, where everything is installed at the Microsoft Azure site, and we have to just subscribe to that and use it as we are using any other product. Advantage is it's in the cloud, and you can take advantage of cloud systems. And its focus of the Azure Machine Learning is on the ability to develop and deploy all the machine algorithm models, and which is usually for the data scientist or the statistician. So data scientists or statisticians develop a model, they train them. As we see all the phases during the model development cycle. So all these phases are supported in the Azure ML, and which provides a very friendly user interface with the drag and drop tools, and it's very collaborative in nature. Along with that, it also provides a wide range of machine learning algorithms, which is developed by which are developed by the data scientists or statisticians. It also has a capability to integrate the R or the Python scripts into Azure ML, because most of the data scientists or the statistician use the R or the Python for developing a model. But if it is already ready, they can easily integrate that thing, and then the data which is provided to the Azure ML can run on those scripts, can be run on those scripts, and they get accepted results. And it's also able to integrate with the multiple data sources, but for our demonstration, we are more concentrated on Azure SQL Azure Data Warehouse, where we have stored our data for previous demonstration, and it's easily integrated with Azure SQL Data Warehouse too. So as we already understood, what are the different phases, starting from problem formulation, data integration, data preparation, modeling. The important step amongst that is about to know, okay, which algorithm we should use for our predictive analysis. So Microsoft Azure Machine Learning provides an algorithm cheat sheet, which actually helps us, the developers, to choose those algorithms, or we at least know, okay, which algorithms to use in which scenario. So as a first step is of course problem formulation. So once we know, okay, what is a problem, then we can decide, okay, the problem fits in which of these categories. So if we have a problem like finding unusual data points, like doing a fraud detection, or just unusual transaction, finding unusual transaction, then definitely we can go with this route and use the anomaly detection algorithms like one-class SVM or PCA-based anomaly detection. If it is firing a discovering structure, we can use a clustering algorithms like k-means. Or if it is like, if the problem is like, okay, we need to predict values, like, okay, what will be the total number of sales in future month, year, quarter, or what will be the predictive performance of employee or the salesperson, like that. Then in that case, there are multiple regression algorithms provided by Azure Machine Learning, and we can choose one of them based on some attributes provided by for those algorithms. If we have a problem, which like we have a first problem is about the predicting categories, which is we have in the first demonstration we are going to see whether the customer will churn or not churn. So it's just a two-class classification, whether it's churn, true, or it's false. So in that case, we can use two-class classification algorithms. Like there are 8 algorithms it's almost 9 algorithms provided by Microsoft Azure Learning, and then we can choose one of them. So for today's demonstration for the customer churn, we are going to use two-class boosted decision tree, which is known for its accuracy and fast training, but it has a large memory footprint. But since I'm right now not using that much large data set, we choose to use this. So if it is the problem of whatever the problem you defined is of the classification of predicting multiple categories more than 2, then also we can choose. There are 5 different algorithms provided by Microsoft Azure Learning, which we can choose one of them. If it is categories are more than 2, like it's guessing, okay, it will be when, or it will tie, or it will be lose. So something like that. If you have a multiple categories which we need to predict in that case. So let's move to the next part. Okay, for the demonstration, first demonstration, we have seen, okay, whereas we already have a data warehouse, we already have a streaming data, we have some big data or unstructured data which is already integrated. So as a scenario, everything is there, and now the next step is, okay, we have everything historical, how we can predict based on the data which we already have in our Azure SQL data warehouse. So this is how our architecture fits over here, and where the Azure Machine Learning comes in the picture. So this is the same diagram we are using for our last two webinars, and we have added the Azure ML in this diagram, which actually is going to connect to Azure SQL data warehouse, where all the data from the different stream is already consolidated over here, and we are just going to use that data. And once the Azure ML started providing the predictive results, we are pushing back that data, the predictive results, we are pushing back to Azure SQL data warehouse, so that we can analyze the data, which is the historical as well as the predictive data in the Power BI. So in the first demonstration of customer churn analysis, we will see how to see the historical churn happen for the customers, and then what the prediction says, and then how also we can compare the predictions with the actuals in that. So we are just going to use this Azure ML for this, providing the data and then getting the results back to it, and then we are showcasing it into the Power BI for the first demonstration. In the second demonstration, since our model is already built, the data is already provided to Azure ML, and the recommendation is already ready. In that case, we are just going to pass some parameters like the user or the product, and then we have integrated the website, which is a retail website in this case, with the Azure ML directly, and then we are getting the recommendation in the real time based on the user or the product selection. So as an advantage, we can also store the data, Azure ML data in the prediction in Azure Data Warehouse. Also, we can integrate directly with your application, which is there. So saying that, this is the overall solution architecture for Azure ML with the integration of Azure ML. Let's move to our first demonstration, which is about a customer churn analysis. So as Renat already explained what is the customer churn analysis, and the idea is to find which customers are going to churn, what the prediction says about which customers are going to churn in next month, or whatever the time frame we define for that. So to identify it, we already know that's a problem. That's a problem definition, that who will churn in next month for this demonstration. The second, so for this, we have used 6 months of sales data for the customer, which the sales data consists of who is a customer, what are the different attributes of customers, and what is the sales happened, in which month the customers provide the transaction happened for that customer. So all the history data we are going to use for this analytics. That's a part of our data injection process, which is a step number 2 for any model development. The next phase is about finding the data preparation or the features, which is nothing but which we have defined. The features which we are going to use for this demonstration is about age, region, total income, number of children, and distance from its office. So we are going to use these features of the customer, and based on that, we are providing that data to our model and saying that, okay, analyze how the churn happens based on these attributes, and then once the analysis is done, we'll train that model and just predict it for the next month. So I will demonstrate to you how we can see the results and how we can run those models over there. And definitely for this demonstration, our main prediction parameter is churn level, whether the customer will churn or it will not churn. So that's what we are going to predict based on the historical data is provided to the model. And as already discussed, we are going to use 2-class boosted decision tree for this algorithm for finding a customer churn. So let's move to the demonstration. So this is the Microsoft Azure Machine Learning Studio, which we use for building a customer churn analysis. As discussed, we already know the problem. We are going to find a customer churn analysis, and then first phase is injection of data. So as discussed, this is a very easy tool where we can just drag and drop things, which we already done and already developed a model. I will just explain you the few things over here. That first we import the data, and then we have to split that data to one part of the data will go to for the training purpose, which we are going to use two-class boosted decision tree algorithm, and then in this case we have used a data up to 4 months to predict the month of 5th, which is the May. So we have a data provided for the training for January to April, and for the May we'll going to predict. So we also have a May data, but which we will also use to compare how the model is how much accuracy model is providing to us. Once the data is provided for training, we'll tune that model, and based on that it will score, which will provide the actual results. And once we evaluate its accuracy, then in the second set we'll provide the actual data set to predict, and then it will provide a prediction which will score that based on this model and this new data. It will score that algorithm and actually provide a predictions for the month. And then we have passed that data to Azure SQL Data Warehouse for the storage, which we will analyze into Power BI. So before this, I will going to show you, just quickly, that as a part of data in preparation, we cannot pass this data as it is into very raw data to the model. We also have to prepare the data and calculate some fields. So for this particular demonstration, we already know who are the new customers per month, and also we know how the churn happened, which based on the past history. So we have calculated these values for each customer, and based on that, we are going to predict which will be churn. So since we already have that historical data, let's see how we can analyze that data into a Power BI. So this is a Power BI dashboard for customer churn analysis. Let me expand it so that you can see it very clearly. Where we have, so this is based on the history. So as I said, we already have a 5 months data, and we already calculated the customer churn ratio, which is nothing but how much percentage of customers churn every month for that particular organization. So you can see here for January, the customer churn was 5.26. In February, it rises up to 8.79. Then it came down to 5.26, then 4.44 in April, and then it again boosted up to 10.68 in the month of May. So if you know, these are the customers going to churn, and if you have some predictive model, then definitely we can, the organization can take action on that, just by providing some promotions or some offers to those customers. So, but we need to know who will going to predict so that we can concentrate on those customers. So this dashboard is providing that facility. This is all based on historical data. And then this provides, how many customers, number of customers actually churn each month. This left side is providing, when it started, in the first month there is no churn because we started from there. So there are no new customers because all customers are already there. But the 5 of them left. In the second month, we gained 12 customers, but also 8 customers left. And then it's similar kind of comparison month to month. It's provided in that how many churn and how many new customers we got in that particular month. And then this side provides the churn happened, but what is the category of that churn? So if the first category is of yearly income, so this saying if the yearly income is between 30,000, we have 2 cases where 2 customers churn within that limit of range. There are 10 customers who left in the overall duration who has 40,000 of yearly income, then they can concentrate on these areas. Similarly, for the commute distance, similarly for age, and similarly for total children, we have analysis that how many customers actually churn by each of these categories. So you can, and then this is this graph provides how many customers churned based on the region. So we know by this graph we can know overall 22 customers knows amongst 33 customers from the California area. So we need to concentrate more on the California area where and just see why the churn is happening and what we can do for that. So this dashboard provides overview of the customer churn happened in historically, and then the next phase is now let's predict something so that we can know now what's going to happen, because this has already happened. We can still work on that contact to those customers, but if you know it in advance, definitely that will be more helpful rather than knowing it once it happened. So since we already have our model ready, let's run the first model. So I'm running it. So what it's actually doing, it's taking, as we already discussed, it's taking the 4 months of data, and in the second section we are passing the 5th month of data, and it's predicting based on that, and it's exporting those results into our SQL Azure data warehouse. So just wait for a couple of seconds. It will take a few more seconds. Then we can analyze, once these prediction results are also available, how we can compare that results with our existing one. So the data is already there in our SQL Azure warehouse, SQL Azure data warehouse, and let's compare that. So let me quickly refresh this dashboard. So so it will take a couple of seconds because it's actually getting that data, and then it's trying to compare the actual versus analytics and trying to showcase over here. Okay, so now we got a prediction for a month of May where we can compare that with the actual one. So as per prediction of our model says that there are 9 customers which are about to leave, but actually in reality it happens the 11 customer actually churned, or they left, or they didn't continue with the organization. So this is how. So anyway, it's in any prediction model, it's not 100% accurate, or we cannot do that, but this is how it's actually showing some results which is very near to what happened to the actual. So this is how we can also compare, and then based on this data you can also provide you can also provide this data back to the model and again retune it so that you can get the more and more accurate results based on. So as the history is long, you will get more good results based. So so this is how results, and then we can actually click on that. I will demonstrate this once I also have a Chum data predictions, that how we can demonstrate this dashboard very easily, and then how we can see each area and then analyze it. So for now, it's actually showing the 9 was a prediction, but actually 11 was there. The next step is we took this data and then again tune it, and in the second model prediction run for the which is for the June, we will know how much now the customers are going to churn in the month of June. So I'm moving back to the second process, which is this process will predict a data for the month of June. So let's run it. So what is happening in right now, it's actually capture the month data up 5 months, all the data up to 5 months, and it's provided that data for the tuning for the 5 months, and then we are passing the customer names for the June's for this month of June, and then we are scoring that of that how much are going to churn. And once that data is predicted, we are again storing that data into Azure SQL Data Warehouse for the comparison. So let's compare this. So I'm just refreshing it so that we can see the Churn prediction in this dashboard. It will just take a couple of seconds to showcase over here. Since actually I'm using a live connection, so one of the way is to use the import query, because the predictions you are not processing on hourly or the minute by minute basis. So once the prediction is done, you can just push that data and then import it into dashboard for continuous analytics purpose. Since I want to show it how it can change, right now I'm connecting to the database directly to get those results. So now you can see the comparison for the prediction versus actual. So for the month of June, it's predicting there are 7 customers who can be churn in the month of June, and our customer churn ratio will be 7.69, something like that. So this is how the prediction it's provided a result, and then once we know the customers who are going to churn in the month of June, we can take an action on that. So let's quickly move to the other same dashboard, but which is already cached, so that we can quickly analyze this data rather than just waiting for the query. So this is the same dashboard, but I have already cached this data over here so that I can showcase you how we can analyze the data for the different parameters. So in this case, right now I'm going to use, let's see the prediction, and which is for the month of June. So we have, there are 7 customers which are going to churn. The ratio will be 7.79. But you can also see amongst those 7 customers how the churn will happen across the different regions. So it's also showing me, in the month of June, there were 3 customers will churn from the California. There are 3 customers from the will churn from the state of Washington, and then there is 1 customer from the Oregon. It's also providing me a distribution like, there is based on this yearly income, how many customers are going to churn for each category. So it says if there are 3 customers, who has a yearly income around 60,000, they are going to churn. So you can concentrate on this area. In this case, for the number of children, so if you have a 0, those are the customers. It's predicted more for this analysis. So you can actually play with this, and then you can just click on just Washington and then see the different results. For just Washington, it's actually 11.11% of churn, and there are 3 customers which you know, but we also know the percentage for the Washington. And then if you would like to see, what was that only for Washington, we can still see, I'm sorry, it's not a prediction. Yeah. So what is a prediction for Washington for the customer churn ratio, and how it's dropping. And so we can click on any area, and then the graph will show you the analysis for each and every parameter, which is helpful for the analysis for finding each and every, to know the churn happened with each and every feature. So this is from the first demonstration for the customer churn analysis. Hope you understand how to once our prediction is there, and how to also analyze the historical data from this demonstration. So let's move back to our second demonstration, which is about the product recommendation. So as we already seen in the first demonstration that, how to build, how to ingest the data, how to prepare data, how to model it, how to evaluate that model. The last step of the model development cycle is about the deployment. So once the model gets deployed into Azure ML, we can also use that model just to retrain it based on the other data, or based on if based on the data which is different from differently. So let's take example. The data scientist already developed a data model which is very generic in nature. It requires some data points, and the other organizations or the user just provides their data to that, and then they can tune their model and then also get the results in the real time, just passing few parameters to it. So we can use it's just not for the existing use case, but it can be used as a model, and then which can be used by the different for the different data sets by the different users or the organizations. So in this second demonstration, I'm going to use existing already deployed a product recommendation model, where the focus is how we can integrate the product recommendation model which is deployed in Azure ML with our existing application. So for this, we have already provided a sales data for the products, which has order details, what products they buy in that particular order, which user purchase what items and everything. That data is all passed to that engine which is already deployed, and then we tune that engine based on the data. And once it is tuned, it's providing it provides the features like, okay, what products get brought together. So once we pass a product ID to it, it provides, okay, these are the products brought together for that. Or if based on the user history, it also provides, okay, what is recommended for the user. So in this demonstration, the prediction parameter is recommendation, which is product recommendation as well as the user recommendation. And as discussed, we already use already built model which is already in the Azure Marketplace, and we have just integrated that with our existing website. So let's move to the demonstration. So I already explained what we have already done. The next part is how we can integrate that with our website. So this is the adventureworks.com website we have created for the demonstration, which has a business of selling bicycles and bicycle-related products. So their use case is, okay, they would like to provide a good user functionality that, okay, whenever user browsing a product or whenever he gets logged in, they would like to show what is recommended for that user, which we are showing in this section, and what is, if based on the product selection, what items people also like when they browse this product, or what is recommended for what is suitable for that product. And that recommendation we are going to showcase over here. So as I discussed, the model is already ready, and we are just passing a parameter and getting that value over here. So first, let's understand how based on the user, how our recommendations are going to change. So let's change the user here. So right now, the user is 11203. So, and for user 110203, these are the 3 products which are recommended for this user based on his previous order history. So let's assume that another user logged into the system, and let's see what is recommended for that user. So if you see, it's just this section is changing because based on that user, it's connecting to our Azure ML website, Azure ML web service, and it's getting that result, okay, for this user, what is already recommended, and then it's just providing that results over here. It's also, that is the first use case of product recommendation. The second use case is about based on the products also, it changes the recommendation of the people who like the above item, what they also like. So let's change the product over here. So I'm changing a product, and then if you notice, it's also changing the bicycle types over here. So let me show you. Okay, for this first bicycle, there are silver, mountain silver, and the red bike was showing as a similar product with like this. If you choose the second one, it's choosing the different bicycles, which is showing the mountain silver and the mountain black bicycle. If I choose a totally different product, like a water bottle, it's going to show me, okay, people who like this item also are interested in buying a bottle cage, which has a different type of bottle cage it's showing, and it's also showing, okay, this bicycle is also suited because most of the people who have this product, they also search for the bicycle, or the bicycle they search, they also have this kind of cage, bottle cage, as well as the bottle. So this is showing very related items for that based on the user recommendation. Sorry, this is for the product recommendation. So now we have seen based on the users, our recommendation for the user is changing, and based on the product selection, our product recommendation is also changing over here, and which we have integrated. It's very real time. The recommendation data is there, the model is there. It's just connecting it to that and then provide it into real time, which is integrated with the application. So this is how we can use our predictive analysis to build your model, as well as we can integrate that in your any existing application. So this is how this is what I have from the second demonstration, which was about the product recommendation. So let's move back to the presentation. So let's review what we have learned from all these or what we have demonstrated you from all the three webinars which we have. So in the first webinar, we have seen how we can migrate existing on-premise data warehouse to Microsoft Azure Cloud and use Azure SQL Data Warehouse as our new data warehouse storage or database. And in the same time, we also seen how we can migrate our existing ETL, which is in the SSIS, how we can migrate SSS and SSS cube and SSRS report. And we also seen in the first demonstration how we can migrate, how we can develop some new dashboards or reports in the Power BI once we migrate our data warehouse to Microsoft Cloud. In the second demonstration, we have seen that once the data warehouse is already in the cloud, how to integrate the unstructured data which can be stored in the Azure Blob Storage. And also we have seen another demonstration that how we can see the real data in a real time in the Power BI using the Stream Analytics engine, where we have seen the demonstration that as a user was viewing a page, we are getting a count, and that it's what updating in the real time. So this is how it's about the second webinar we talk. And in this today's webinar, we have seen how once our full-fledged data warehouse is there, we know their historical data is already there. Now the next and the last phase in the graph is about the predicting, and then the last phase is about the prescribing, that okay, what is prescripted based on the data, that also we can build using Azure ML. So we have all the data which is in Azure SQL data warehouse. We built a models based on top of that, and then we analyze the data, for the business user purpose, as well as for the end users. We have also integrate the Azure ML so that our users are also getting the advantage of the predictive analytics, where they can see the recommended products, which will help companies to upsell or the cross-sell their sales. So that is what we have from all these webinars, where we have demonstrated each and every product in the Microsoft Azure data platform, and the demonstration will showcase how easy to use the Microsoft Cloud platform. Saying that, thank you everyone for attending this webinar. I'm handing over back to Renata.
Thank you so much, Sunil, for showing us these two demos. And now we can see that once we are in cloud, yeah, especially we are using Azure Data Warehouse, we can focus more on analytics and not so much about infrastructure. So we can also perform predictive analytics for many business cases. In fact, those two, we can build it with the help of Azure, because Azure already have some model that can help us to jumpstart the model development. And from the marketplace, you can select all the algorithm, the model, and also the evaluation. So you can talk to your stakeholder and then persuade them to do some POC, proof of concept, to build the model, and then start showing them the many of business advantage of using predictive analytics for your business. So thank you all for listening. Thank you for attending. And if you have any question or you need any services from us, anything related with data warehouse, BI, or analytics, if you want to build something on premise or migrate it to the cloud or build a new one in the cloud, you want to integrate the big data, you want to use machine learning, we have people, we have data scientists, data professional, and software developer, and we can work together. And feel free to contact us. This is our email. So Megan, do you have any question for us?
Thank you, Renata and Sunil. That was a great presentation. We do have a couple questions, and if anyone else has any questions that they can think of right now, please feel free to type those in as well. Our first question is, I have large data sets that I would like to run predictive models on. How do I get that data to Azure so I can run Azure ML on it?
Okay, yeah. So definitely the large data set is we have to see what is the format of that large data set, that if it is in the file structure or it's unstructured. If we have Azure, as shown in the presentation, we have Azure Blob Storage where we can push everything in the file format to Azure Blob Storage. If it is in a database, we can migrate it to SQL Data Warehouse or Azure SQL Data Warehouse, and then based on that, we can provide that results directly to the Azure ML. So first step is to get that data into cloud and then run into the Azure ML. So, but it's not just the Azure ML or running the predictive analytics is not about just get a data, we have to also prepare a data. So if you have, once you have all the data for the model, what kind of data is also required, that also we have to think, and then we have to write some scripts or transform that data, which needs to be directly provided to Azure ML. Or Azure ML Studio also provides a facility that you can directly connect to these databases and then transform it over there.
Yeah, basically following the model life cycle that we have in the circle that we show in the beginning of this presentation.
Yeah.
And also utilizing all those models provided by Azure, that will be helpful in this case, I think.
Right. So yeah, means large data set, that's actually the advantage of Microsoft Azure, where you can store any size of data over there, irrespective of its format. So we can also use data lakes where also, yeah, thank you.
Perfect, thank you. We do have another question. What are the minimum requirements to run a predictive ML model? Can we run simply on VLOB and ML development kit?
Yeah. Yeah. So we can run it on. So there is no it's a software as a service. So it supports the large data sets as well as the small data sets. So there is no minimum requirement in terms of data. But yeah, if your data is so if it's just 1 month data and still you want to predict for the second, probably we have to decide the model based on that. So there is no limit as such, you can say. You can predict anything, but it's based on the historical data, the predictions will be different. So I'm not, so is that a question? Am I answer it correctly, or let me know if it is a different one?
I think also because the ML, this is we're using Azure Data Warehouse. Yeah, we can still connect Microsoft Machine Learning, Azure Machine Learning, to the rest of the application in the Azure Data Platform. So if you have blob, we have blob. If you have big data, we have big data. You have a relational database, we have relational database. All is in Azure, and they are all integrated. So no need to worry about that. That's my answer for that.
Yeah.
Okay. And as a follow-up to that question, do we need to have MSBI?
No. So that's if you already have a MSBI.
MSBI is MS Data Warehousing.
Microsoft BI.
Azure Data Warehouse.
Yeah. So MSBI, it's like a tool. If you're talking MSBI, I understand the tools like SSIS, SSAS, RS. But for machine learning, it's not required. Machine learning, it's required a data source, which can be anything from your files, from your database, or from your data lake, or whatever, or Hadoop structure. That can be also a source for machine learning. So it's not required we have to use MSBI for that.
Okay, thank you. Another question that we have is, why is training the predictive analytics model required?
Okay, so actually, if you see our traditional BI system, it's mostly about the historical data. We analyzing it, and we are also focusing on, okay, we should provide that data more accurately to the users. So now, in terms of predictive analysis, that accuracy, reliability, or we can say the credibility of that model is also required. That okay, whatever result the prediction is provided by that model, how much it's accurate and reliable, and definitely it's credible. It only come once we start comparing that results. So training actually provides experiment or the observation based on the past data. So it's the training is doing, okay, this is what happened in first month, this is what happened in the second month. So then it's derived some formula, okay, what is the pattern over there. Now it also has a third month data. So based on the first and second month model, it's also say, oh, for third month, this is what happened. So this is how it's actually, because since we use the boosted decision tree, it's actually comparing each trees like that. So it's actually providing, okay, whatever the historical data we have, it has to find some pattern and then provide a new data to get a better results for that, which we can say it's more accurate or reliable for that. So if you don't train and then just run it on the first model, then probably the accuracy or the reliability of the prediction cannot be trusted so much. So since we have that data and based on the data, some model has to be derived. We train that data saying, okay, this is what happened and this is what the model is. And now you say, oh, but this happened next month. So this, oh, actually, let's tune it more, something like that. So that's the reason training is more required for this model.
Yeah, to optimize the model,
yeah.
So we have more credibility and the result is better.
Right.
I think that's the main objective.
Okay, and this last question I can field, the last one is, will there be any more webinars in this series? And there will not be more webinars in this series, but we will have more coming based around cloud analytics. If anyone in the audience wants to suggest any topics, we are certainly open to suggestions. If there are no more questions, thank you all for joining us today. We really appreciate you taking the time out of your day, and thank you, Renata and Sunil, for your very interesting presentation. If you have any more questions, I will wait on the line for a few more minutes just in case. Otherwise, please enjoy the rest of your day. Thank you all.
Thank you.
Thank you.